Good morning, viewers. This is Kasturi Day. Today, I'm going to again discuss the atomic structure according to ICSE syllabus class 8. So in my last video, I was discussing about the radioactivity. Okay, so according to this radioactivity, what is the Professor Smith, Madam Mary Curie, Pierre Curie, they all discovered certain elements that produced certain emissions. Okay. And they found that some elements, they radiated some, there was some phenomena which showed that some elements emit certain radiations, okay, which penetrated certain even which could penetrate some any of the objects, okay, like uranium. They are the radioactive elements. Thorium, radium, polonium, these are all radioactive elements. So what is radioactivity? It's a phenomena due to which some elements can emit highly penetrating radiations spontaneously. And according to Ernest Rutherford, these radiations consisted of three kinds of particles. One is alpha, gamma, and alpha, beta, and gamma particles, gamma radiations rather, alpha particles, beta particles, and gamma radiations. Okay. Now, alpha particles, they were positive in nature. They are positive in nature, containing 2 protons and 2 neutrons. It's the nuclei of helium. Okay, they have +2 unit charge, and they have 4 AMU mass, which are slightly deflected by electric and magnetic fields. They have least power of penetration through the matter. Okay, through the matter they can penetrate in, very less amount of alpha particles could penetrate this any matter. Okay, next is beta particles. Beta particles have minus unit charge, and they have negligible mass, but they are strongly affected by the electric and magnetic fields, and they can penetrate through 5 millimeter of aluminum and 1 millimeter of lead. But gamma radiations, they are the powerful radiations, you can say. They have a wavelength which is less than X-rays, but they have no mass and no charge on them. But they can penetrate 30 centimeter thick iron also, but they are not affected by electric or magnetic fields. Okay, next we come to these radioisotopes. These radioactive elements, they also have isotopes which are known as radioactive isotopes. Okay, these are generally artificially made elements. Okay, so when normal elements are bombarded in nuclear reactors, their nucleus captures 1 or more neutrons. And due to this, their neutrons become unstable, and therefore they radiate nuclear radiations. So normal elements bombarded in the nuclear reactors, which capture 1 or more neutrons, and this becomes unstable, thus radiating nuclear radiation. So these are artificially made elements which are known as radioisotopes. And therefore, the isotopes of elements which are prepared by subjecting them to neutrons bombardment, these are known as radioisotopes. Okay, clear? Next, we come to certain radioisotopes, which has the symbol, radiations, half-life, and their uses. Okay, see, tritium, they have a symbol of 3 mass number. 1 is the atomic number. Beta radiation, they have half-life is 12.33 years, and use is biochemical treasure they are used for. Then carbon 14, which has a mass number 14, and 6 is the atomic number, beta radiation it is, and it has 5730 years, which is used in archaeological dating. Then phosphorus 32, they have the 32 as atomic mass number and 15 as the atomic number. Again, this is also a beta radiation, and having 14.26 days half-life, and leukemia therapy it is used for. Then potassium 40. 40 is the mass number, 19 is the this is atomic number. Beta radiation again 1.28 into 10 to the power 9 years is its half-life, and it's used for geological dating. Then cobalt 60. 60 is the mass number. 27 is the atomic number. Beta and gamma radiations both are there. Beta particles and gamma radiations both are there. 5.27 is the half-life years. Then cancer therapy it is used for. Then technetium 99M, which is 99M is the mass number for technetium, and 43 is the atomic number, where it has a gamma radiation 6.01 hours its half-life, and it's used for brain scans. Then iodine 123. 123 is the mass number. 53 is the atomic number. I is the symbol. Gamma radiations, again, it's used for thyroid therapy, and half-life is 13.26 hours. Uranium 235, it is 235 is the mass number. 92 is the atomic number. Alpha and gamma radiations are the radiations which are given out by this element. And 7.04 into 10 to the power 8 years nuclear reactors it is used for. Next, we come to the harmful effects of the radioactive radiations. What are the harmful effects? See, we have learned the useful effects. Now we come to the harmful effects. So these radiations, as nuclear radiations, are highly penetrating. That is, they can penetrate matter, whatever thickness, mainly the gamma radiations, they have a high penetrating power. That's why they can easily pass through all living things. And they bring about changes while passing through with the living things. They bring about the changes in the genes that generally can cause cancer. Okay. They also bring about changes in the reproductive system that can cause, give birth to defined babies. Okay. Some abnormalities in the babies, it can happen. Okay. So these are the harmful effects which are found in the as the radioactive radiations happen. Okay. Now, what are the useful effects? Useful effects that they can cure cancer. By allowing these radiations, we can kill the cancer cells in a controlled amount. If we focus these radiations in a controlled amount on these cancerous cells, then we can cure that. We can kill those cancerous cells. They also used to irradiate fruits and vegetables by killing the disease-causing bacteria which is present on them. And so we can store them for a longer period without refrigerations. So they are useful in keeping the fruits and vegetables fresh without refrigeration. Okay, by killing the bacteria which is present on them. Okay. Next is nuclear energy, which is fission and fusion. Okay. Now, what is nuclear energy? It is the energy which is stored in the nucleus of the certain heavy metals like uranium and plutonium. Certain heavy metals like uranium and plutonium, they have certain amount of energy which is stored in the nucleus, in their nucleus. Okay, that energy is known as nuclear energy. It is also known as atomic energy. Okay. Then the nucleus of those elements is split by slow moving neutrons that release large amount of energy in the form of heat and light. Okay, the nucleus of those elements is split by slow moving neutrons. If we pass slow moving neutrons to these elements, to the nucleus of these elements, they start releasing a large amount of energy in the form of heat and light. That is known as nuclear energy. Okay, this energy which is stored in the nucleus, that comes out. Okay, that is nuclear energy which comes out in the nucleus, that is stored in the nucleus. The process of splitting the nucleus of heavy atoms to form lighter nuclei or lighter atoms, lighter nuclei of the atoms, that is known as nuclear fission, splitting. Okay, breaking up the nucleus of heavy atoms into lighter nuclei. Okay, then this energy can also be produced by fusion of the nuclei. One is by splitting the nucleus, another is by fusing the nucleus. Okay, two nuclei getting fused. Okay, that of lighter elements will fuse, and heavy atoms, heavy atomic, heavy atoms of the nucleus of heavy atoms, that will split. Okay, so two processes are there. One is nuclear fission, that is breaking up of the heavy atom nucleus, or nuclear fusion, where the lighter elements, the nucleus of the lighter elements, they join together at very high temperatures, extremely high temperature and pressure, forming a stable heavy nucleus. That is also known as nuclear fusion. Okay. Now, example of fusion of hydrogen atoms at around 10 million degrees temperature. See how high the temperature is. Just imagine 10 million degrees temperature and 1 million times atmospheric pressure to form helium nucleus. Okay, with the release of tremendous amount of energy in the form of heat and light. This is fusion, nuclear fusion, this happening. Okay, next we come to another, see, this is also fission and fusion about I'm discussing about. Most of the nuclear energy is obtained by nuclear fission of uranium and plutonium. Okay, so most of the nuclear energy that comes from the nuclear fission of uranium and plutonium. This process is performed by controlled way in specially designed machines, which is known as nuclear reactors, by slow moving neutrons to produce electrical energy. Okay, so in the last point, we discussed that nuclear fusion is happening. Okay, two lighter atoms, that nuclei of two lighter nuclei of the atoms of lighter elements, that is combining, that is hydrogen, we are combining and forming helium. Okay, but very high temperature and very high pressure. But it is noted that most of the nuclear energy that comes from nuclear fission, that is splitting of the uranium or plutonium. And this process is how it is done. It is done by controlled way in a specially designed machines. Specially designed machines are there, which is known as nuclear reactors, by slowly moving the neutrons to produce the electrical energy. Okay, as this produces a lot of heat, this heat is used to raise the steam, which in turn used to run the turbines coupled with electrical engine generator. Okay, that is how electrical energy is produced. Okay, so what do we do? This first, in the nuclear reactor, we pass slowly moving neutrons, and we see that it produces certain energy, electrical energy. Okay, and in that process, a lot of heat is produced, and this heat is used to raise the steam, and which is used to turn the turbines, and that turbine is used to run an electrical generator. So when the blades of the turbine rotate, the heat energy of the steam is converted into electrical energy. Okay, when the turbines rotate, blades of the turbines rotate, no, that produces the heat energy, and that heat energy changes the steam into electrical energy. But the waste product plants are very dangerous. Waste product plants, where these when the nuclear reactors are working, where the nuclear energy is being converted into electrical energy, the waste product plants, where some waste products are there, that are very dangerous to living beings. The persons who are working there, that is very dangerous for them, because that can cause the nuclear waste, that can cause cancer, leukemia. Leukemia is also a cancer, it's a blood cancer. So cancer of the skin or any parts of it, the leukemia or etc., and even can spread to over thousands of kilometers in case of any accident happens to those plants. Okay, say this is the nuclear reactor, where you can see this is the pump through which the water is going. See, first this reactor core, here it is, there's a controlled rods which controls the neutrons to pass through. Then here the water is passing, the water is getting converted to steam. Then the steam is allowed to run the turbine. Okay, this is steam which is coming out from the water. It is being This is water which is getting into steam. Then steam is going to run the turbine, and this is turning the electrical generator. Okay. And as it is a large amount of heat is there, so its condenser is used to little bit cool it. Okay, warm water is coming through, and again cool water is coming out. So it's cooling down a little bit. Okay. Next is the safety measures which are taken in the nuclear plants, because I told you it's very dangerous for the persons who are working there. So to stop any leakage, not only the persons who are watching, the outside persons, or if any leakage happens, then that can cause a very disastrous circumstance outside also. So need to be very careful to stop any leakage of the gamma radiations or the neutrons. The nuclear reactors must be embedded in thick concrete walls. So the nuclear reactors, they have to be covered with, they have to be embedded in the thick concrete walls. Okay, the nuclear materials must be kept in thick lead containers with narrow mouth plugged with thick lead corks, that so that they cannot leak out, the radiations do not leak out from the lead, pass through the lead. Then workers must wear lead lined aprons and gloves, and also special lead glasses to protect their eyes. Okay, generally the lead does not allow the radiations to pass through. Then nuclear material should be handled with mechanical tongs. Then workers must wear special firm film bandages, and that can absorb the nuclear radiations, which can be tested to find out the amount of radiations which has been absorbed by the particular worker. How much radiation the worker has been absorbing, that can also be tested if they wear film badges. Okay. Then a periodic medical checkup of the worker should be done. If a person is found to be overexposed to the nuclear radiations, then he must be immediately withdrawn from the nuclear establishment. Okay, so this is all about this atomic structure. Okay, and hope you have understood this chapter. Still, if you have any doubt, you can please write in the comment box. You can also access to my email ID, that is kasturi74@gmail.com. And I hope you are liking the video. So press the like button, and do also share with your friends so that they can also be benefited from these videos. And do subscribe to get the notification of my next videos. In my next video, I'll be discussing the question answers of this chapter. And after that, I'll start with the class 9 syllabus. Okay. So stay tuned. I'll be back in my on Friday. Okay. So thank you. Thank you for watching, and have a good day.